The views and opinions in the following program remain those of the producer or sponsor, and not those of Medford Community Cablevision, its staff, management, board of directors, or other affiliates.
Hi, welcome to MathMan. This is the second part of our series, and I promised at the beginning we'd try to make math a little more fun for people. Well, it's spring, and if you're a Boston resident, what do you think of mostly when it comes to springtime? No, it's not flowers, it's not birds, it's the Red Sox. The Red Sox are going to be playing, and as of this show is done, they just finished 3-game series with the Rangers, and they didn't win a single game, which is unfortunate. And of course, the screams are the season's over already, are already happening from all the boo birds. But if you're a Red Sox fan, you just love to go to the game. Tonight's program, I'm dedicating it to 3 special people. They're all sports people, they're all baseball people. One is my father. He saw his first game at 6 years old, and he was able to see the Red Sox win a series again. The other one is Al Rocky, better known as Slick down in South Medford. He worked at Fenway Park for about 50 years as an usher, and I saw a picture of him with Babe Ruth. And he knows baseball inside out, and Johnny Pesky is a good friend of his. And another one is famous in Medford, was the former editor, sports editor of the Medford Mercury, Al Frezza. I owe Al a debt of gratitude for all the help he's giving me over the course of my life. So for Frank, Al, and Al, this program's for you. Oh, and a person needs to be mentioned as being one of the better athletes that Medford's produced, our own council president, Bob Maiocco. And if you're my age, then you remember Bobby at school, and he was a pretty good athlete. Okay, let's get started with the idea. Baseball's been around for over 100 years, and it was one of the premier sports all through the 30s, the 40s, and the 50s. Yeah, there's basketball, and we have the Celtics, and there's football. But if you're an older person and you like sports, there were 2 sports that you had. You had baseball and you had boxing. And I remember sitting up on Friday nights with my father watching the Gillette Friday night fights. But baseball is where the action was. Going over my Uncle Joe's house in Wilmington with all my cousins on a Sunday and watching the Red Sox, we all sat around. And one of the things that what always happened with sports is that we all have our own opinions, and we all have arguments as to who the better player, what the better player is. But there's one thing that sort of differentiates players, and that's statistics. And that's what tonight's show is about. We're going to get into some simple statistics that you see on the baseball pages of the newspaper, or you go online, and what do they really mean? But don't forget, one of the most important things about statistics is where does the information come from, and you have to interpret it. For example, you've seen the ads about 4 out of 5 doctors recommend something. What if they recommended Bayer aspirin? Well, it'd be kind of strange if those doctors all came from the laboratories of Bayer aspirin and only 4 out of those 5 recommended it. So it's important as to where we get our information, where we do our cross-sampling, and especially with the political season coming up soon, it's going to be very interesting with the polls. From when they talk about who's ahead and who's behind, and they polled, 1,000 people. Were those voters? Were those people? Were those people from the same state? So just be aware, statistics are important. One of the biggest statistics, one of the most important statistics, the one that we look at first when we think about baseball, is the winning percentage of a team. And it ranks the team as to what division is in. If it's the American League, the National League, if it's the East, the West, the Central, and they all have their tiers, and they're ranked by how many wins you have. Well, how do you figure out the wins? Well, it's simple, and the numbers they have are in 3 digits. So a team is always like .645, and it's a percentage, really, of how many games they have won. For example, if a team plays 8 games and they have won 4, they are at 500. Now, to go to the World Series, it's almost guaranteed you've got to get above 500. Right? You've got to be a better team to do it. But that's how they do it. They divide the 8 into the 4, and they get actually what it comes out to be is 0.5. And I think the newspapers will present it as 3 decimal places as 0.00. Now, batting average is probably the second one that people understand and people look for. Batting average is pretty much the same thing, but there are limitations to what it is. A batting average is how many hits does a player get opposed to how many times he's been at the plate. But it's not really at the plate because there are some things that are taken away. If a player makes 10 plate appearances 10 times, and it's the beginning of the season, and after one game a person can be batting 1,000, which is perfect. But if they make 10 plate appearances and they get 3 hits, it's 3 hits as compared to 10 plate appearances, they're really only doing, and I say only because they're batting at 30%. Now that sounds horrible, 30%. Imagine your job, if your job was to make pizzas and you only made 3 out of every 10 pizzas correctly, we'd probably be fired. Well, in baseball, batting 30% is darn good. And it's not portrayed as 30%. And I think the reason they do it is because 30% sounds pretty bad. But that same number, represented a different way, as 300, which we're all more familiar with, it certainly sounds a lot better. So you've got Big Papi batting 300. That sounds better than saying Big Papi is batting 30%. But what happens to those 10 times at the plate? Well, those 10 times at the plate don't represent every single time a person comes to the plate because you subtract some things that don't count. A walk doesn't count as a time at the plate. Even though the person went to first base, it doesn't count. Other statistics, and we'll get into those, take that into consideration because a person's on base. He can score a run, and that's important. But they don't count that as part of his batting average. If he hit by a pitch, they don't count that. A sacrifice fly, they don't count that. So they take those pieces out. And at the end, they have the number of times you're at the plate, divide into the number of hits, and you get 30%. Probably the most recognizable average there is in all the sports. Now, basketball has, shooting percentages from the line and how many three-pointers you make as opposed to how many you've tried. And all these things give us a measure of how to measure one player against another player. There are a series of statistics, and some of them are simple. Now, I went on the web and I printed out, it's 4 pages of batting statistics, pitching statistics, and simple things that actually don't even involve any calculation. For example, there's one called 1B, which is singles. And it's just a list of how many times did a player get a single when he was up at the plate. There's nothing to take away from it because it's a single. Now, an error doesn't count as a hit, but a single. So a person can be compared to another player by having 10 signals, and another person had only 4. Now, what about doubles? Same thing, 2B. Is a double better than a single? Yeah, so a double's more important. But, compared to doubles, you can compare players. So they came up with a statistic that takes into consideration, if I hit 10 singles and you hit 10 doubles, well, you've done a better job. So how can we represent that so that it's a better representation of what sort of a player you are? Well, they have something called slugging percentage. And this has come out recently, it's come to the forefront recently because people have realized the slugging percentage is really important. Let me get that for you. And it's almost like an algebraic problem. And I think when I was doing this out and just writing it out, I realized that's why a lot of people don't like algebra, because it takes simple words that are translated and it makes it more difficult. So over here we have slugging percentage, SLG. Right? Now, here's where it gets, I'm sure, pretty annoying to people. It's how many singles plus how many 2 bases. Now, all these are just representations of a single or a double, and you could have written the word in there too. Okay? Plus how many triples plus how many home runs, and you can see they're all times the number of bases. 1 base, 2 base, 3 base, 4 base. So what they're saying is if you hit a double, that counts as twice as much as one single, and a triple, and so on and so on. And you divide that by the number of times of at-bat. Now, some significance of those. I'm not going to do those calculations because you can do those yourself. Let me see if I can find the paper that I had here. And it had Babe Ruth holds the Major League Baseball career slugging percentage. His slugging percentage is .690. Now, he never hit .690 as a player for a batting average, but his slugging percentage was so high, and the reason it was so high is because he had so many 2, 3, and 4 base hits. And let me read to you what it says here. It says, for example, in 1920, Babe Ruth played his first season for the New York Yankees. In 458 at-bats, Ruth had 172 hits, his first season, comprising 73 singles, so you'd put 73 here. He had 36 doubles, plus 2 times 36. He had, let's see, 9 triples, 9 times 3, plus 54 home runs. So those all represent, 1, 2, 3, 4, 5. Okay, here we go. 1, 2, 3, 4. And for a total of 388 total bases. 1 base, 2 base, 3 base, 4 bases. Right? And when you divide that by his total at-bats of 458, he has 846. I'm sorry, 847. The next year he hit 846, and these records went unbroken until 2001 when Barry Bonds achieved 411 bases in 476 at-bats, bringing his slugging percentages to 863. Now, Babe Ruth's 690 was over the life of his career. That's an incredible feat. And because if you've seen the pictures of Babe Ruth, he was rather portly at the end of his career, a strong man, but to be able to hit that and be on base that many times makes you extremely valuable. Now, that doesn't include the times he walked, which is another time that he was put on base. Okay. Now, as you can see, it's very possible and pretty likely that you're going to have a slugging percentage that's certainly higher than your batting average. Okay. Let's change one thing here about on-base percentages. So you have batting average, slugging percentage. What about your on-base percentage? Now, the on-base percentage takes a few other things into consideration. It takes his hits, which these are. Those are his hits. It also takes his walks because he's made it to base. And here's one thing it takes hit by pitches. The times that the batter was hit by a pitch because he also made it on base. And I really do like formulas, and they make it a little easier to understand once you understand the lingo or the jargon that's going on. So let me put this one in. This has no numbers at all in it. It's the on-base percentage equals the hits plus BB, which is, of course, base on balls, hit by a pitcher, pretty simplistic, divided by his at-bats. Don't forget, that's his at-bats that does not include his walks and being hit by a pitcher, plus base on balls, plus hit by a pitcher, plus sacrifice flies. These here are not included in his average when you figure out someone's batting average. So when you see someone batting 300 as the first example we put on, it doesn't include the times he got hit by a pitch, he walked, or he had a sacrifice fly, he moved the runner along, or he moved the run in. Right? So you get those number statistics, you put it in. If you've ever kept score with baseball, with the book when you watch the baseball game, because when we played Little League down in Spicer, that was sort of a challenge to do it as we were all young and all learning to do it. There's a certain notation and a certain way you keep score. And there are people who are dedicated fans who have those scorebooks going back tens of years. And it's just interesting to do it because it's just like playing chess and having chess notation, and you can go back and you can reconstruct the game of chess you just played by following what happened, and you can reconstruct the baseball game by following what went on in someone's notebook. So the on-base percentage. So we have the average, the batting average, slugging average, and on-base percentage. And those, of course, can be different depending if you're getting more multi-base hits or not. There are people who walk a lot. And there are people who are set out there. There are players that are the first player out, and they take a lot of walks, and they want that first runner on, as you know if you're a fan. So that's someone who's important. You could theoretically have someone, it's ludicrous to think it would happen, but someone who have a batting average of 0, that they never got a hit, but every time they were at the plate, they got on first base because they were walked. Okay. Let's move on a little bit to some of the pitching averages. Now, this is the one that we look at for pitchers most of all. It's called the earned run average, ERA. And unfortunately, after 3 games with the Rangers, you've got some pitchers that have some very high ERAs. And usually at the beginning of the season, the ERAs are much higher than at the end of the season if you're any sort of a decent pitcher. And when you understand how it works, you'll see. It's the one that most people have asked, how do you figure out the ERA? Well, the ERA, earned run average, is, let's see, earned runs, we'll put runs, and I'll put an E here because they're earned. If there's an error, they don't count. The earned runs divided by the innings pitched times 9. The runs scored against the pitcher by the innings that the pitcher pitched times 9. So I have a couple of examples, and let's throw it out as the beginning of the season, and I think you'll see it. Let's say there were 2 runs and 1 inning pitched. All right, so we have 2 runs dividing by 1 inning pitch equals 2. Multiply it by 9 equals 18. Horrible. Horrible earned run average. And we'll get into what good earned run averages are in a few minutes, but that would be horrible. Okay? And someone pitching for 1 inning gives up 2 home runs and they yank them out in the first inning of a game, in the first game of the season. That's his earned run average. He's not going to get any big bucks by anybody. So, how about someone who has, let's see, 2 runs over 6 innings. Same amount of runs, different innings. You've got 0.333 times 9, and basically what you get is an earned run average rounded off to 3. So just by pitching a few more innings, you can see, even though you scored the same number of runs, it's different. And this keeps going on and getting added on as the year progresses, and you'll see good earning run averages, you know, between 2 and 3, great ones, less than 2. Okay. Now, let's take a look at some statistics that have been accumulated over the course of time. And my little chart over there, this represents, and I got this from the web because I was interested as to what some of the better players were doing. Now, this is batting statistics for the years that were accumulated between 2004 and 2008. Okay? These are all pitching statistics, rather, between those 2 years. All right? So, this column is going to represent the top 5 pitchers. And this column is going to represent the best pitcher in those years between 2004 and 2008. Okay? Well, these are batting statistics. I haven't got to the pitching yet. So the batting average, top 5 averaged 321. And it's always referred to not as 300 and 321 thousandths or 0.3 to 1. It's always is hundreds. It's 321. And the best for that year and the best for those years were 372. So obviously there had to be people less than that, and there are some people above it. The number of home runs by the 5 best averaged 37. And the best for those years was 58. RBIs, run batted in. Once again, that's not a calculation. That's just something you add up and is cumulative over time. And runs batted in, for the top 5 guys, they averaged 124 runs batted in. And the best one, 156. And the slugging percentage, as opposed to the batting average, and I'm glad they're on the same chart. The best one, or the 5 average rather, was 571, and the best one was 812. And it gives a good comparison for batting average and slugging percentage. And let's just look at the best person. The best person hit 372, and yet his slugging average was 812. He was probably the person who hit the 58 home runs. He probably got an awful lot more, home runs than anybody else because it counts as 4, because there's 4 bases to it. Okay. Now the pitching chart gets involved with some of the things we didn't get involved with today, but I'll try to weed it down a little bit. Okay. We have the stats, we have the top 5, and we have the best. Okay? So here's some interesting things that if you're an older guy like me, you don't see much more of. Complete games. This is when a person starts and it goes all the way to the end. The top 5 in those years, they averaged 3 complete games. The best person had 9 complete games during the years 04 to 08. The earned run average, the one we just figured out before, the top 5 added 3.19, and the best 1.87. The games, the number of times a person started to pitch and he pitched in a game, 77 was the average, 94. Doesn't mean he had to start, it just means he showed up for the games. One of the ones they watch very closely, an inning pitched. It's sort of how durable a pitcher is. 225, and the best did 255. Ks. If you watch the game on TV, you know what a K is. A K is a symbol for a strikeout. The average of the top 5 pitchers for those years, they averaged 206 strikeouts, and the best was 290. Saves. Saves represents a complicated formula of how to do it, and I'd read it to you because I have it here, but it's just too much to remember. You can go on the web and you can find it out because it involves a few different things. And the saves, the average was 38, and the high was 62. And the one that everyone looks at for a pitcher, how many games did he win? And the average of the top 5 pitchers in those years was 17, and the one that won the most was 22. It's not often we get a 20-game winner anymore, and it's been very rare we get a 30-game. I think McLean might have been the last 30-game winner that there was. It took an awful lot out of him. Well, I hope this has been somewhat helpful about statistics for the games. If you're a little eager, you should be keeping your own statistics. You should be writing down what you do at the plate, how you hit it, and you can break it down to things like how many pitches did you take? If you struck out, did you strike out on 5 pitches? Did you strike out on 6 pitches? What was it that you did? Because looking at those numbers and looking at numbers everywhere gives us a better idea and a better indication of how things work. Too many of us fly by the seat of our pants with things and we think things are okay, but yet when we see them in numbers, it really makes a difference. I had a friend who bought a house and he was looking to buy the house. He made an offer. And the difference in his offer was $1,500 over the price of what the gentleman who was selling the house. And he didn't want to do it because he said he didn't want to go that high. We sat down, and when I showed him that the difference in price, that $1,500 translated, if he borrowed it, it translated to, I think it was $7 a month more on his mortgage. And I looked at him and said, for $7 a month, you're not going to get the house that you want. $7 a month seems to be a lot different than $1,500 all at once. He bought the house, and he just finished paying off his mortgage. And he loves it being there, and I'm sure it was a good thing for him to do. Well, we have just a minute or two. One of the things, this involves a lot of percentages, but percentages are related to fractions, they're related to decimals, and it's a real simple thing. 1/2, as you know, represents 5/10, which represents 50%. They can be interchangeable, they can be used. If a person was to hit 400, they're really hitting 40%. They add that 0 again and they make it 400. Last person to hit 400, you know, was Ted Williams. I have a few other statistics here, and I think, well, how about this? The player, all-time leaders for on-base percentage. Ted Williams, .481. Babe Ruth, .470. How about Lou Gehrig? .447. Barry Bonds right behind him, .444. Ty Cobb, .433. Jimmy Fox, another Red Sox, .428. And Albert Pujols, .425. Single season leaders, on base percentage. Barry Bonds is number 1 for the year 2004. He's number 2 for the year 2002. Ted Williams is the year 1941, and he was 551. Babe Ruth, 1923, 542. Then Barry Bonds again, 529. Babe Ruth again. Ted Williams, Billy Hamilton, Barry Bonds, and Ted Williams. So out of the top 10 times, 1, 2, 3, 4 Barry Bonds, 3 Ted Williams, and 1, 2 Babe Ruths. You can get statistics to do what you want them to do. You can get them to represent things, and those things may or may not be important, and that's where it comes into what do the statistics really mean. Thanks for watching. I appreciate it. I hope this is helpful. I know a lot of you understand all this, but sometimes your mate might not, or a friend of yours might not, and hopefully this will help you out. And when you go to a baseball game, have a little more appreciation for some of the managing things they do, because managing, thanks to Tommy LaRussa, depends so much more on statistics than just managing by the seat of the pants. Thanks for watching. You've been watching MathMan. I'm Ron DeLucia. We'll see you again.